Okay, 12.4 is basically looking at relationships between perimeters and area. So if you look here at these pictures here, this one right here, the side is equal to 3. The perimeter would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the area would be, there's 9 squares in there, right? Okay. But look at this one right here. I've got the side being equal to 5, the perimeter being, so there's 5, 5, 5, so it's going to end up being 20, and the area is going to be 25. So if I think about ratios here, the ratios of the sides are 3 to 5. I'm just doing the first to the second. The ratio of the perimeters are 12 to 20. If I reduce that, I get 3 to 5. The ratio of the areas are 9 to 25. I can't really reduce that, but there is a way that it's related to this. And if you think about it, 9 is the same thing as 3 squared, and 5 is the same thing as 5 squared. So basically, the areas are in the ratio of the side ratio, but it's squared. Okay? So it says down here, if the scale factor of two similar figures is a to b, then the ratio of their perimeters is also a to b. That's what we saw up here. The sides were 3 to 5, so the perimeters are also 3 to 5. The ratio of the areas are a squared to b squared. Again, we saw that here, the 9 to 25 we can get by doing the 3 squared and the 5 squared. So down here, if it says two similar polygons have corresponding sides and ratio 5 to 7, what's the ratio, larger to smaller, of their perimeters? Remember, the sides are 5 to 7. That's small side to the large side, so it would be 7 to 5 if I did larger to smaller. The perimeter is the same thing as the sides, so this one is also 7 to 5. The areas, I've got to take that 7 and square it. I got to take that 5 and square it, so it's 49 to 25. If you want to write them with a fraction, like 7 over 5, 49 over 25, that's fine. You can do it that way too, okay? Okay. This idea is important because then it can help me find other things if I'm missing something. So finding area using similar figures. So it says the scale factor is 3 to 4. Remember, this is just the ratio of the sides. And they're two similar parallelograms. So one is like, the sides are just 3 to 4. It could be 3 and 4. It could be like 6 and 8, but they're in the ratio 3 to 4. The area of the larger parallelogram is 96. And then it says, what's the area of the smaller parallelogram? This problem is asking me about areas, so I can't use the side ratio. I need to find the ratio of the areas. So the ratio of the areas is 9 to 16, because it's 3 squared over 4 squared, which is 9 over 16. So now I know that 9 over 16, and again, I've got small over large here. Oops, that should be an L, not a 4. So I got small over large. So they told me the area of the larger one is 96. So the larger one is on the bottom. And here I just cross multiply. And then and I cross multiply, I'm going to divide by 16. So I end up with getting x is equal to 54. The units are the same, we're going to say inches squared. Okay? So again, I had to switch this problem to find the ratio of the areas. I could not use the ratio of the sides. All right, this one, it says the scale factor of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. How much should the larger piece cost? This is the scale factor. This is just the sides. If I want to figure out cost, I need to be thinking about area. Okay, so I've got to switch things here. So the ratio of the areas is 3 squared over 5 squared, which ends up being 9 to 25. So then I can use that 9 over 25. Now in this one, it told me the smaller one is 250. So this, I have small over large. Again, you don't have to always do small over large. You could have large over small, but just make sure you line everything up. Small over large, small over large. Again, I'm going to cross multiply here. I'm going to do my algebra, and I get that cost for the larger piece. All right, the next one says finding perimeter ratios. So here it tells me the area of two similar rectangles are that. What's the ratio of their perimeters? All right, this one doesn't tell me the smaller one to the larger one or the larger one to the smaller one. So I always just go the first one to the second one. So right now, this is the ratio of the areas. So the area ratios are in this number right here. If you remember from that first page there, we said that the areas were a squared to b squared. So if I wanted to go back to the perimeters, I would have to take the square root. And what you're going to find in these problems, though, sometimes is it doesn't work right away. So if I take the square root of 1875, I get an ugly number, okay? Likewise, if I take the square root of 135, I get an ugly number. So sometimes what you want to do is reduce these first. So if I do 1875, there's a little trick on your calculator. Divided by 135, ugly number. But if I hit that math button, and then I use the frac, so I press enter, and I press that again, it tells me that this reduces to 125 over 9. So what I did for this problem is first I reduced. So I reduced. But remember, I told you on that first page, this is still the ratio of the areas. It's just reduced now. So now I need to take the square root. Well, the square root of 9, so now I'm going to get the ratio of the perimeters. I need to go from here to here. Now I'm ready to take the square root. So the square root of 9 is 3. The square root of 125, unfortunately, I get something ugly there. Mathematicians do not like to have decimals within the fraction, so I don't want to have a decimal in my fraction. So I'm going to simplify my radical. So 125, the biggest perfect square that goes into that is 25. If I take 125 divided by 25, I'd have 5 left over. The square root of 25 is 5, so that's out of the radical. And then I just still have this 5 underneath the radical. So that's the ratio of the perimeters there. All right. So just like before, let's look at a couple of these problems. Kids generally, I don't know why, but they always seem to forget. You got to change it to the ratio of the areas when you're doing an area problem. I don't know. It's just like something that we're just supposed to forget, I guess, apparently. So if I look here, let's see here. All right, let's look at 14 first, because again, these are kind of just ones that kids forget how to do. So here, so number 14, it says I have similar figures there. The area of one figure is given, and then it says find the area of the other figure to the nearest whole number. So the first thing I'm going to do is to find the ratio of the sides there. So I'm going to do 12 over 18. So this is of sides here, which is going to reduce to, so let's see, 2, they're both divisible by 6. Okay, so 2 to 3. Then the ratio of the areas, I've got to square that, so I get 4 to 9. All right, so it tells me the area of the larger trapezoid. So I have 4 over 9 is equal to 121, because the 9 is bigger, is related to the larger one, and then my x is up there. I cross multiply, and I end up getting like approximately 54. It says I can round it to the nearest whole number, so 54 meters squared when I solve that one. All right. Let's look at let's see here, 24. All right, 24 says find the scale factor and the ratio of the perimeters for each pair of similar figures. So in 24, what they're telling me here is that I have two circles with areas of 2 pi centimeters squared and 200 pi centimeters squared. So right now, the scale factor is 2 pi to 200 pi, okay? These cancel. This is 1. This is 100 now. This is the, sorry, this isn't the scale factor. This is the ratio of the areas. So if I want to get the scale factor, so I reduced it first here. To get the scale factor, now I'm going to take the square root. So the square root of 1 is 1. The square root of 100 is a 10. So that's the scale factor. The ratio of the perimeter, remember this is A to B, the perimeters are also A to B, so it's also 1 to 10. All right, and then lastly, let's look at 35. All right, 35. So for 35, it says find the values of x and y when the smaller triangle shown here has the given area. So a couple things. So this is 35. So I know that that smaller triangle, so 1/2 base times height, so that answer there is equal to 6. So 1/2 x times y. So then x times y is equal to 12. So that's one thing that I know there in 35. All right, so the larger triangle is the area is 1/2, and it is 8 times 12. So that larger triangle has an area of 48. Okay. The ratio of the, and again, I know I didn't really need to do this actually. So the ratio of the areas is 6 to 48, which ends up reducing to 1/8. The scale factor then, so I would take the square root. So the scale factor is 1 to 2 square roots of 2 then. Because again, if I take that square root of 8, I'm going to get a weird answer. So 1 to 2 square roots of 2. So now, if that's the scale factor, what I can do here is basically set up two proportions. So I could have 1 over 2 square roots of 2. So that's the scale factor. This is the 1. This is the 2 square roots of 2. Is equal to, I can do x over 8. And then I can use that scale factor again and do y over 12. So then I can cross multiply both of those here. What ends up happening here is I end up getting, eventually, x will be 2 square roots of 2. You're going to have to simplify that radical. Down here, when you cross multiply, y will be 3 square roots of 2. So basically, you've got to take the areas, take the square root to get the scale factor, then go back and use the ratio of the sides to find the x and y. Okay?